Hello everyone. In this video, I have discussed the nomenclature of organic compound with functional group using IUPAC rule. I have already shared the nomenclature of alkane, alkene and alkyne in my previous videos. If you find my videos helpful, then please like and subscribe to my channel. Let's get started. Let us start with the simplest one, haloalkane, also known as alkyl halide. Halogens are always treated as substituent and prefix halo is added to the name of a compound. For example, CH3Br. This compound is obtained by the substitution of hydrogen with bromide in methane. So, bromomethane. There are two chlorides in the second compound, so dichloromethane. Similarly, the third one is trichloromethane. If there is only a halide substituent, then the numbering is carried out in such a way that the carbon attached to halogen gets the lowest possible number. In this given compound, if the numbering is done from the right end, the substituent fluoride will get a second position, while if it is done from the left end, it will get a fourth position. So its correct name is 2-fluoropentane. Similarly, the lowest position of a substituent in the second compound is 2, and the longest carbon chain possesses 4 carbon atoms. So its IUPAC nomenclature is 2-bromobutane. If there are two substituents, one halide and one alkyl substituent, or two halide, the numbering is carried out using the least sum rule. In this compound, if the numbering is carried out from the left end, the locant of fluoride and methyl substituent are 2 and 4, whose sum is 6. While if the numbering is carried out from the right end, the locant of fluoride and methyl substituent are 4 and 6, whose sum is 10. So based on the least sum rule, the numbering from the left end is correct. So its IUPAC nomenclature is 2-fluoro-4-methyl-heptane. For more detail on the least sum rule, please go through my previous video on the IUPAC nomenclature of organic compound. The link to that video is given in the I button as well as in the description box of this video. Consider the second example. If the numbering is carried out from the left end, the locants are 3 and 6, whose sum is 9. While if the numbering is carried out from the right end, the locants are 2 and 5, whose sum is 7. So based on the least sum rule, the numbering from the right end is correct. So its IUPAC nomenclature is 5-fluoro-2-methyl-heptane. Similarly, the IUPAC nomenclature of the first organic compound is 4-ethyl-2-fluoroheptane and the second compound is 4-bromo-2-fluoroheptane. If the two substituents are present at an equal distance from either end, we do the numbering according to their alphabetical order. In this compound, the substituents are fluoride and bromide, and alphabetically bromide will come first, so it is 2-bromo-6-fluoroheptane. Similarly, the IUPAC nomenclature of the second compound is 4-ethyl-6-fluorononane. If there are three substituents, we carry the numbering using the rule of the first point of difference. If you find difficulty in understanding the concept like least sum rule and the rule of first point of difference, then I would strongly recommend you to watch the first part of this series. Okay, for example, the locant of these three substituents from the left are 2, 5 and 7, and from the right end the locants are 3, 5 and 8. So based on the rule of first point of difference, 2, 5, 7 is correct, and thus its IUPAC name is 7-bromo 5-ethyl 2-fluorononane. If a double or triple bond is also present along with the halide, the lowest number will be given to the unsaturated carbon. In this compound, the numbering must be carried out from the left end to give more priority to a double bond. Hence, numbering must be carried out to give a priority to double bond. So, its nomenclature is 4-fluoropent-2-ene. Similarly, the second compound is 4-fluoropent-2-ene, as there is a triple bond at carbon number 2. If the double bond and triple bond are present along with the halide, we carry the numbering using the rule of the first point of difference. Consider this example. There is a double bond as well as a triple bond. So, numbering must be carried out from the left end. So, its nomenclature is 4-fluoropent-3-ene 1-ene. Similarly, in the second compound, the numbering must be carried out from the right end based on the first point of difference rule. So, its IUPAC nomenclature is 2-fluoronon-3-ene 5-ene. Okay, next is alcohol. The longest chain of carbon atom must include a hydroxy group, and these compounds are named by adding suffix -ol in place of E alphabet of the corresponding alkane. For example, CH3OH, it is methanol, CH3CH2OH, ethanol. While numbering, give the lowest possible number to the carbon bearing the hydroxyl group. Like in this example, the numbering should be carried out from the left end so that the carbon attached to the hydroxy group gets the lowest possible number, which is 2. So, its IUPAC name is butane-2-ol. If there are 2 or more hydroxyl groups, then add suffix like diol, triol, depending upon the number of hydroxide group present in a compound. In such cases, the alphabet E of an alkane is retained in the name. For example, as you can see, OH, CH2, CH2OH, there are 2 hydroxyl groups. So, its nomenclature is ethane-1,2-diol. As you can see, we have retained the alphabet E of alkane. A hydroxyl group is a functional group and it takes priority over alkyne and halogen substituent as well as on the double and triple bond while numbering the parent chain. The unsaturated alcohol are named by replacing "ane" with the suffix "enol" or "vinol" of the corresponding alkane. In this organic compound, the numbering must be carried out from the left end so that the carbon attached to the hydroxyl group get the lowest possible number. There is a methyl substituent at position number 3 and bromide at the position number 4. So, its name is 4-bromo-3-methyl-pentane-2-ol. In the second compound, the numbering must be carried out from the right end. You can see that the parent chain has 6 carbon, and there is a double bond at position number 5. So, its IUPAC name is hex 5-ene 3-ol. In the third compound, there are 2 alkyl substituents beside a double bond. The locant of ethyl, methyl and doubly bonded carbon are 3, 4 and 5 respectively. So, its IUPAC nomenclature is 3-ethyl 4-methyl hex 5-ene 2-ol. In the fourth compound, there is a triply bonded carbon atom at position number 3. So, its IUPAC name is 3-ine 2-ol. Next is ether. The general IUPAC name for ether is alkoxyalkane. Ether are those compounds that contain an oxygen atom connected to the two alkyl or aryl groups like RO, R dash. The longer carbon chain is named as an alkane, whereas the chain with a lesser carbon chain is named alkoxy and is always written as substituent with the number specifying its position. Let me illustrate using a suitable example. Consider this example: CH3O CH2 CH3. This is the simplest example of ether. There is a methyl group at the left of the oxygen atom and an ethyl group on the right of the oxygen atom. Ethyl is bigger and longer in terms of carbon chain, so it will consider as an alkane, and the smaller methyl group adjoining with the oxygen atom will be considered as the substituent. So its IUPAC name is methoxyethane. In this compound, first we will select the longest possible carbon chain. There are 4 carbon, so it is butane. Now the ethoxy group is attached to butane through carbon number 2, so its IUPAC name is 2-ethoxybutane. In the third compound, the longest possible chain has 3 carbon atoms and there is a methyl as well as methoxy substituent at the carbon number 2. So its IUPAC name is 2-methoxy 2-methyl propane. The fourth compound is symmetrical and has ethyl on either side. So it is a ethoxyethane, which is commonly known as diethyl ether. Consider some typical example of ether. In this compound, the parent chain is propane, wherein there is a methyl substituent at position number 2 and there is an ethoxy substituent at position number 1. So its IUPAC name is 1-ethoxy 2-methyl propane. In the second compound, the parent chain is pentane, wherein there is a bromide substituent as well as an ethoxy substituent. Using the least sum rule, the numbering remains the same from both ends, that is 2 and 4. Since alphabetically bromide will come first, so the numbering will be carried out from the left end. So its IUPAC name is 2-bromo 4-ethoxy pentane. In the third compound, the longest possible chain has 5 carbons. Using the least sum rule, the numbering must be carried out from the right end to give a doubly bonded carbon atom and methyl substituent a locant of 1 and 3 respectively. Moreover, there is a chloride attached to the methoxy group. Its IUPAC name is 1 in a bracket chloromethoxy bracket close 3-methyl pent 1-ene. Similarly, the fourth compound is 1 dash in a bracket 2-fluoro propoxy bracket close but 2-ine, and there is a triple bond in the alkyne chain at position number 2. Next topic is aldehyde. The longest carbon chain must contain the aldehyde, that is CHO group, and the carbon of the CHO group gets the lowest number. They are named by suffixing al in place of e of the corresponding alkane. In general, an aldehyde is named alkanal. For example, HCHO, the smallest aldehyde, is named methanol. CH3CHO, ethanol. As mentioned earlier, the chain is numbered from the aldehydic carbon, but the position of the aldehyde is not specified by the number 1, as it is understood that the aldehydic carbon is the terminal carbon. Consider this example: 5 carbon, so pentanol. In the second compound, there is a methyl substituent at position number 2. So its IUPAC name is 2-methyl-butanol. Since the chain is numbered from the aldehydic carbon, the aldehydic group takes priority over alkyl halogen substituent as well as double and triple bond while numbering in the parent chain. For example, in this compound, the numbering will start from the aldehydic group. There are 2 methyl substituent at position number 2 and 4. So its IUPAC name is 2,4-dimethyl-pentanol. In the second compound, the numbering is carried out from the right end. So its IUPAC name is 5-bromo-3-methyl-hexanol. If the compound has 2 aldehydic groups, it is named as alkane diol, such that the alphabet E of the alkane is retained. For example, butane diol. In the second compound, the numbering must be carried out from the left end as per the least sum rule. So its IUPAC name is 3-bromo-2-methyl-hexane diol. The unsaturated aldehydes are named alkynol or alkynol depending upon the double bond and triple bond. This is but-2-enol. For the second compound, the numbering is carried out from the aldehydic group, which has a position number 2 and 4, which give position number 2 and 4 to methyl and triply bonded carbon respectively. So its IUPAC nomenclature is 2-methyl-pent-4-enol. Next is ketone. Likewise, aldehyde, the longest carbon chain must contain the ketonic group, and the carbon of the ketonic group gets the lowest possible number. The ketonic are named by suffixing -one in place of E of the corresponding alkane. In general, ketonic is named alkanone. For example, in this compound, there are 3 carbons, so propanone. This is the smallest ketone. In the second compound, the ketonic carbon is at position number 2, so its IUPAC name is butan-2-one. As mentioned earlier, the ketonic group takes priority over alkyl and halogen substituent as well as double and triply bond. So as per the rule, the numbering in this compound must be carried out from the left end so that the ketonic carbon gets the third position. So its IUPAC name is 5-methyl-hexane-3-one. Similarly, the IUPAC name of the second compound is 6-bromo-4-methyl-hexane-2-one. The unsaturated ketone is alkinone or alkynone depending upon the presence of a double or triple bond. For example, this compound has a double bond, so its IUPAC name is 5-methyl-hex-4-ene-3-one. And the second compound contains a triple bond, so its IUPAC name is 5-methyl-hex-1-ene-3-one. If the compound contains 2 ketonic groups, it is referred as alkane dione. The alphabet E of the alkane is retained in such a case. For example, 2,4-pentane dione. Consider a typical compound with 2 ketonic groups. Here the ketonic groups as well as the methyl substituent will get the same position number from either side. But because of the chloride substituent, the numbering has to be due from the right end. You can also use the rule of first point of difference. The IUPAC name is 1-chloro-4-methyl-heptane-2,6-dione. Carboxylic acid. The longest carbon chain must contain carboxylic acid, and the carbon of the carboxylic acid gets the lowest number. The carboxylic acid is named by suffixing oic in place of E of the corresponding alkane. They are referred as alkylic acid. For example, HCOOH, methonic acid, CH3CH2COOH, propionic acid. In the third compound, there is a methyl substituent at position number 2. So, it is 2-methyl butanoic acid. As mentioned earlier, a carboxylic acid group takes priority over alkyl, halogen, double bond, triple bond while numbering the parent chain. Consider this example. The longest possible carbon chain has 5 carbons. As the numbering has to carried out from the carboxylic acid groups, the 2-methyl substituent will get locants 2 and 4, while the ethyl substituent will get locant 3. So, its IUPAC name is 3-ethyl 2,4-dimethyl pentonic acid. In the second compound, the numbering has to do from the right end. So, its IUPAC nomenclature is 5-bromo 3-methyl hexonic acid. The unsaturated carboxylic acid is called alkylic acid or alkyonic acid, depending upon the double bond or triple bond present in the compound. This first compound is 2-methyl pent 3-enoic acid, and the second compound is 2-methyl but 3-ionoic acid. If the compound possesses 2 carboxylic acid, the longest chain should include both carboxylic group. These compounds are termed alkane dioic acid. It is written without specifying the position of the carboxylic group, as both the functional group are present at the end of the parent chain. For example, ethane dioic acid. It is also known as oxalic acid. The second compound is butane dioic acid, which is also commonly known as succinic acid. Some acid derivative: acid halide, acid anhydride, ester, and acid amide. They are named as alkyl halide, alkylic anhydride, alkyl alkynate, and alkane amide respectively. Let us start with the acid halide, RCOCl. The nomenclature of acid halide or any other acid derivative start with the name of their corresponding carboxylic acid. The IC acid ending is replaced with the ending YL, followed by the name of the halogen with an ide ending. The carbonyl carbon is given the first position, and its location number is not required to be mentioned in the nomenclature of the acid halide compound. In this compound, the numbering has to do with the carbonyl carbon, so it is propanyl chloride. In the second compound, there is a methyl substituent at the position number 2, so it is 2-methyl butanyl bromide. Similarly, the third compound is 3-bromo 2-methyl butanyl chloride. In the fourth compound, besides methyl substituent at position number 4, there is a double bond at position number 5, so its IUPAC name is 5-methyl hept 5-ene oil bromide. Acid anhydride. A symmetrical acid anhydride is also named like carboxylic acid, except the ending acid is replaced with anhydride. For example, ethanoic anhydride and propionic anhydride. The unsymmetrical acid anhydride are named by first naming each component of carboxylic acid arranged alphabetically, followed by a space, then the word anhydride. For example, there are ethonic and propionic group in this compound, and alphabetically ethonic will come first, so its IUPAC name is ethonic propionic anhydride. Similarly, the IUPAC name of the second compound is butonic ethonic anhydride. Ester. They are named as alkyl alkanate, where alkyl and alkanate refer to an alcoholic and carboxylic part of the molecule. They are named as if the alkyl chain from the alcohol is a substituent. No number is assigned to this alkyl chain. For example, the alcoholic part is methyl, while the parent chain of the carboxylate part has 2 carbon, so its IUPAC name is methyl ethionate. Similarly, ethyl propionate. In the parent chain of the third compound, there is a double bond, while the alcoholic part is a butyl. So its IUPAC name is butyl 2-methyl pent 4-enoate. The alcoholic part of the fourth compound is isobutyl. So IUPAC name of the fourth compound is isobutyl 2-methyl butanoate. Acid amide. An amide can be primary, secondary or tertiary. Primary amides are named by changing the name of acid by dropping the oic acid or IC acid and adding amide. For example, propanamide, as there are 3 carbon in the parent chain. Similarly, 3-bromo-butanamide. The secondary amides are named by using an uppercase N, capital N, to designate that the alkyl group is attached to the nitrogen atom. The alkyl group attached to nitrogen atom is named as a substituent. Consider this example. There are 3 carbons in the parent chain and the methyl substituent directly attached to nitrogen of amide. It is secondary amide. Its IUPAC name is N-methyl propanamide. Similarly, the IUPAC name of the second compound is N-ethyl 3-methyl butanamide. Tertiary amides have 2 alkyl groups directly attached to nitrogen atoms of amide. They are named in the same way as secondary amides, but the 2 capital N. Consider this example. The 2-methyl substituent directly attached to nitrogen of amide, so its IUPAC name is N-dimethyl propanamide. Similarly, the IUPAC name of the second compound is N-dimethyl 3-bromo-butanamide. Alkyl cyanide. The alkyl cyanide is named as alkane nitrile. The longest chain must contain the carbon of the cyanide group, which gets the lowest number. For example, methane nitrile, ethane nitrile. In the third compound, there are 2 substituents at position number 2 and 4. So its IUPAC name is 4-bromo-2-methyl butane nitrile. Alkyl isocyanide. The isocyanide are named as alkane isonitrile. However, unlike cyanide, the carbon of isonitrile is not included while selecting the parent chain. This is due to the fact that isocyanide, the carbon atom of isocyanide ligand is not involved in the bond formation with the parent chain. So, methane isonitrile, propane isonitrile. Nitroalkane. The nitro group is always considered as prefix, as it is always considered as substituent. For example, nitromethane. In the second compound, bromide will get the priority as nitro group is always considered as a substituent. So its IUPAC name is 1-bromo-3-nitro-butane, amines or amines. The longest carbon chain must include the carbon attached to the NH2 group or amine group, and the lowest possible number is also given to that carbon. Amines are named by suffixing amine in place of E of the corresponding alkane. The general name for amine are alkanamine. For example, methanamine. In the second amines, there are two alkyl substituents attached to the nitrogen. Its name is 4-chloro-butane 2-amine. In the secondary amine, there are two alkyl substituents. So first longer chain is selected as a parent chain, while the other alkyl chain is named as prefix and written as N-alkyl before the parent chain. For example, there are two alkyl groups, methyl and propyl. So methyl will be considered as substituent, while propyl is a longer chain considered as a parent chain. So its IUPAC name is N-methyl propan 1-amine. The IUPAC name of the second compound is N-methyl propan 2-amine, as the NH group is attached to second carbon of the longer propyl chain. In tertiary amines, there are three alkyl substituents. First, the longest chain is selected as a parent chain, and the other two alkyl groups are written as prefix as N and dialkyl if both of them are same, or N-alkyl if the both of the substituent are different. In this compound, there are three alkyl substituents, among which two are methyl group. So its IUPAC name is NN-dimethyl propan 1-amine. In the second compound, there are three different alkyl groups attached to the nitrogen, among which the propyl is the longest one. So its IUPAC name is N-ethyl N-methyl propan 1-amine. Next is thioalcohol. The IUPAC name for thioalcohol is alkane thiol. The lowest possible number is given to the carbon bearing the SH group or thioalcohol group. For example, methane thiol and 3-methyl butane 1-thiol. Sulfonic acid. The general IUPAC name is given as alkane sulfonic acid. The longest carbon chain include the carbon having a sulfonic group, and that carbon get the lowest possible order of numbering. For example, ethane 1 sulfonic acid and butane 2 sulfonic acid. Now I end this video here. Thanks for watching. If you find my videos helpful, then please like and subscribe to my channel. See you in the next video of this series.